Hello everyone. So what do we have? We have this TV board. This TV board is coming from a TV technician, and the story about this TV board is saying the TV is not coming on, is not doing anything. This is a smart 40-inch Sonitec TV motherboard that came in for repair. I tried to give him some different motherboards, but it's not working. So we are forced to fix this motherboard. So let's see what this motherboard is doing exactly. We have the AC. That's the AC power cable here. Let's see if this power cable is plugged. Let's plug it on power source. So that's the story. We see the standby light is flashing. Pay close attention. Yeah, it's flashing. That's all what this motherboard is doing. So let's disconnect this LVDS for the screen. We don't need it now. Now, after disconnecting, we now have red light on. It's not working. No matter how many times we press the power on switch, it's not even responding. So we have a problem. So if we have standby light, we'll pay attention on the secondary. Because if we have a standby light, that means the high voltage area is okay. Maybe something's wrong on the secondary side. So what we can check? Can we check the 5 volts power supply for the standby? Yeah, we can check the 5 volts. What else can trigger to this fault? Can be the processor, or what I found can be the switch itself, or it can be anything. But let's check some voltage. What do we have on the secondary? 12 volts. 12 volts, we have a 5.8 volts. That's not right, because here on this connector I must have 12 volts. 5 volts coil, 4.8, which I believe is fairly fine. Here I have another coil, 1.22. Here another coil, 3.3. All the capacitor, electrolyte capacitor looks fine. You can check the motherboard. All the electrolyte capacitor looks fine, but still we don't have a working motherboard. So this coil is outputting 5 volts. Let's see here on this connector we must have 5 volts. On the last pin, (3.3), 2 volts. We have 3.25. Here is meant to work with the 5 volts for the standby. So the standby voltage is low. We have 3.28 instead of 5 volts. So why the driver is outputting 3.3 instead of 5 volts. Let's go under microscope and have a look. Let's check under microscope. Which one is the driver? Maybe this one. Maybe that's the driver. Zero volts on this pin. 2.59. 3.28. 3.29. Okay. So I want to disconnect the power and come with 5 volts on this coil and see what current is being drawn here. Because this can be faulty. This fault can be tricky on the coil, on the 5 volts power supply. It's taking. It's taking 100, 200 milliamps. Okay. So that doesn't mean that we have a faulty driver, or the driver can be faulty. This driver can be faulty. Checking to ground. Let's check how many ohms. Like 5 mega ohms. So the resistance to ground, I would say there's no problem. Maybe we might have problem with the driver. But why? Here we have the optocoupler. We have this optocoupler. That's the optocoupler. Here on the input, or on the primary stage of the optocoupler, we have 2 pins, which is a transistor without base. We have only emitter and collector here, and the emitter is going to the driver. This one, the other pin, is going to ground. And on the secondary here, we have an LED which is controlled by light. We have a photo transistor here. So this optocoupler is being controlled. We have a regulator on the output, which I believe is this small thing. We have an on shunt regulator here, and in order to have a 12 volts and stable 12 volts, this shunt regulator has to work. So I will check voltage on this shunt regulator. I'll check the voltages. What voltage do we have there? Volts. On this pin we have 0.3. Here we have 1 volt. Here we have 0, 0. So I don't believe. Let's start. You know, when everything is working, but it's when you have all the voltages and it's not working, we can start with this shunt regulator. But the problem, next to the shunt regulator, here we have an electrolyte capacitor, and we need to isolate this capacitor from heat. So what I'm gonna use this. I'll do this. This is the nozzle of a water station. I'll isolate this electrolyte capacitor and we'll try to take out this shunt regulator. Maybe that is our fault. Maybe that's our fault. Okay. Let's check out this shunt regulator. Let's try to look for a different regulator. Okay. Let's try to replace this regulator with another one. That's the one. 431. Let's see if that can solve the problem. Now we need to cool down this. We just save this electrolyte capacitor from blowing up, because those capacitor, they don't want too much heat. Those electrolyte capacitor, because here we must have 12 volts all the time on this connector. See this connector? We must have 12 volts there, and we have 5 point something volts. That is the reason why I'm suspecting a faulty on, and it's now what have changed. It's no longer flashing, and we now have a bright red light. Let's check the voltage. Let's check the voltage straight away on that 12 volts power line on this connector, and we now have 12 volts. You can see. So this motherboard probably was not turning on due to a fault shunt regulator. Let's try to power it on. On. No, it's not even powering on. Let's change this cable. Need another cable. Maybe. Let's see. It's not responding. But we can't conclude that this switch is fault. Because if there was no 12 volts there, it means this board was not going to work with a fault shunt regulator. But let's try with a different switch. It's red, pressing, and it's changing to green. You see, it's working. So how am I going to get satisfied that this motherboard is working? Let's turn it off. I can't turn it off, but it's on. Voltage on the backlight circuit. 21 volts. Let me look for some strips. LED strip, and then we test. So what did I found? I found these strips. I'm sure they are for 40-inch or 42-inch. So we need to test to see if these strips they are working. So what I will do, I'll plug it here. I don't know how I would do it. Let's plug the power. We want to see if these LED strips they are coming on after I've turned on the motherboard on, and they are working. You see, so yeah, it's working. It's working. Let's disconnect here. You see, so we now have a working motherboard. So yeah, that was the fault of this smart 40-inch smart TV motherboard for Sonitec. Our fault was the shunt regulator. That is the easiest way to check if you have a fault shunt regulator. Check the 12 volts power supply from the connector. On every motherboard, we have a connector which is meant to have 12 volts all the time. If you see we have like fluctuating of voltage, or we have a lower than 12 volts, the first suspect is the shunt regulator. Because what this shunt regulator is doing is just regulating some voltage on the output of it's managing the optocoupler. So like, subscribe, don't forget to turn on the notification bell for future updates, and if you have anything that you don't understand, don't hesitate to leave a comment, and I'll try to answer you on the next repair. Bye.